Today we will be discussing about two topics. The first one is logarithm. The second one will be differential calculus, okay, or we call it differentiation, okay. So the first one is logarithm, okay. Now this logarithm we can write, okay, in a short form maybe, or like say the symbol of logarithm, okay. So that is log. Okay, so for any mathematical calculation we did not write logarithm, instead we will write log, okay. Now for example 36, okay, we can represent this 36 in the form of 6 to the power 2, isn't it? So like 6 into 6 will give 36 only. So instead of 36 I can write 6 to the power 2, okay. So let me just rub this one, okay. Now logarithm definition is this. See, the log of this value is 2 for the base of 6, okay. So that means for this particular form we can represent in the form of logarithm, that is we write log of 36, okay, is equal to 2 for the base 6, okay. I hope you are clear with this one. Let us try out some few more examples, okay. Say suppose 81, okay. 81 I can write as 9 square, isn't it? Now if I have to represent in the form of log or logarithm, okay, then I write log of 81 is 2, okay. So the log of 81 is the power answer, okay, that is 2, and of base 9, okay. So another example, okay, another example, that is 100 we can write in the form of 10 to the power 2, okay. Now log of 100 is equal to 2 for the base 10, okay. So you see this 100 should be here, and the value of log 100 is equal to 2 if the base is 10, okay. Now let me give you some problems, okay. You solve it by yourself, okay. The first one is like 4 we can represent in the form of 2 square, okay. Then second problem is 8 we can represent in the form of 2 to the power 3, okay. You solve these two problems by yourself and just try it by yourself and then tell me whether you could solve it or not, okay. So you have to represent these two questions in the form of logarithm, okay. So that is about the logarithm. Now let me give you 2 formulas for logarithm, okay. The first one is log of product, okay, the product, that is mn, okay, or you can take uv also, okay. So log of mn equals to log of m plus log of n, okay. Then the next one is quotient, okay. So log of m by n is equal to log of m minus log of n, okay. So these are the two formulas that you have to keep in mind, okay, for logarithm. So that was all about logarithm. Now we go to differentiation, okay, or we call it differential calculus, okay. So differential calculus, okay. See, we have two types under calculus. One is differential, okay, or differentiation. The other one is called the integration, okay. So or integral calculus, okay, integral calculus. Now in a simple way, like integral means summation or addition, or maybe like increase in the number, okay. Differential calculus or differentiation means there is a reduction or subtraction is there, okay. So that is the simple meaning of differential calculus and integral calculus, okay. So for differential calculus, if you apply differentiation, okay, or if you apply differentiation, then the final answer will be less than the initial value, okay. And for integral calculus, okay, if you apply integration, then the final answer will be more than the initial answer, okay, or the initial value. Okay, so we will deal in this video only with differential calculus. So differential calculus we represent, okay, in the form of d by dx, okay, in the form of d by dx. This is the representation of differential calculus. If it is integral calculus, then we would have represented by this symbol, integration of dx, okay. This one we shall learn later on, okay. Now let us go with this differential calculus. Okay, so you keep in mind this one, d by dx. I'll explain you about this one also. So let us just write it here, okay, somewhere on top. Now let us take one example, y as a function, okay, y equals to f of x. You might have learned in your class 9 and 10, see, polynomial, isn't it? Like p of x equals to x cubed plus 2x squared and so on, isn't it? Now this p of x is a function, okay. This p of x can be taken as function, okay. So if y is a function where y equals to f of x, then by differential calculus we can do it this way, okay. In order to calculate through differentiation, then we will write d by dx of y, okay. So then after that the formula follows up, okay. Okay, now here I'll tell you, see how we read this one, okay. So the differentiation of y, or the differentiation of function y with respect to x, okay. Say for another example, d by dt of y or x, anything, okay. So here this means differentiation of y with respect to t, okay. Now remember that the denominator, okay, the denominator is an independent variable, okay, and the numerator is, this is a numerator, okay. So the numerator is a dependent variable. Now usually t is time, okay, time is independent. Suppose if we consider ourselves and the time, okay, we are dependent on time, time is not dependent upon us, okay. So in case of differentiation, the denominator, okay, the denominator, okay, the denominator is an independent variable and the numerator is a dependent variable, okay. There are several formulas for differentiation, but then we shall deal with only one type of formula, that is for now, okay. Maybe in the other videos or other classes I might give you some extra formula, okay, but as of now let us deal with this one only. So d by dx of x to the power n equals to n x to the power n minus 1, okay. Now say for example we are asked to differentiate for x squared, okay. Then how we do is d by dx of x squared, okay, equals to, see here the power is n, here the power is 2, so we will write 2 instead of n, I'm writing 2, okay. Then x is x, then n is 2, so 2 minus 1, so equals to 2x to the power 2 minus 1 is 1. So this is the final answer. Now in the beginning I told, like for the differential calculus, okay, differential calculus, I told that final answer will be less than the initial value, okay. So see, x squared is more, isn't it, than the final answer, okay. So final answer is always less, okay, in case of differentiation or differential calculus, okay. Let us try another problem, okay. Let us try the next problem, that is for x cubed, okay. I have erased the formula, and okay, just let me just write it for you here, okay. X to the power n equals to n x to the power n minus 1, okay. This is the formula. Now for x cubed, if I differentiate d by dx of x cubed equals to, so 3x 3 minus 1 equals to 3x 2, isn't it? So this is the answer, okay. So that was all about differential calculus. Now I'll give you one problem, okay. I'll give you one problem, that is x cubed plus x squared, okay. We have to differentiate for this one, so implies d by dx of x cubed plus x squared, This is how we have to write, isn't it? Now in the next step, see, we can multiply d by dx with this one and d by dx with this one. Okay, so it will be d by dx of x cubed plus d by dx of x squared. Okay, so the answer that we have is, like, we have already solved for this one, okay, this set and this set. So I'll just write it for you, okay, directly. So this is how we will get for the final answer. Okay, now I'll give you 1-2 formulas for this differential calculus, okay, that you will be needing like some basic formulas. Okay, there are plenty of formulas, but then let me just give you 2 formulas. Okay, one is of the product u v. It will be u d by dx of v plus v d by dx of u. Okay, then the other formula is d by dx, that is of quotient, so this u by v is equal to v d by dx of u minus u minus u d by dx of v divided by v square. Okay, so these are some of the basic things that you have to know. Okay, that is all about these 2 topic in this video. Okay, if needed, I shall explain to you in other videos more about this differential calculus and also logarithm. Okay, for logarithm there is one more thing. We have to know how to find out the log value from the log table. Okay, there is anti-log as well, so you have to learn those methods. Okay, you can check out in Google and find out the answer. So that was all about logarithm and differential calculus.